Slide 1. The Ocean Environment, Unit 02A, Part 1, Physical and Chemical Conditions in the Ocean. Slide 2. Living in the ocean is very different from living on land. In this section, we will explore some of the physical conditions in the ocean which marine organisms must be able to tolerate and take advantage of to survive and prosper in the ocean. Slide 3. The density of water is about 1,000 times greater than the density of air. This means that water provides a great deal more support than air. In other words, water pushes upwards on an object a lot more than air, helping it fight gravity. You probably know from your own experience that you can lift up and carry someone in a swimming pool whom you could never lift up outside the pool. On land, we must use strong muscles, attached to strong, heavy bones, and spend lots of energy to fight the force of gravity so that we can move around. In the ocean, the water itself lifts organisms up. So, ocean animals spend much less energy than land animals to move around, because they do not need to be able to support their own weight. This is why the largest whales are larger than the largest land animals that ever lived, the dinosaurs. It is much easier to be large and move around in the ocean than in air. Another good example is gelatinous animals, jellies. Without the support of water, gelatinous bodies collapse into a pile of goo. Even if an organism's density is greater than the density of water, the water still provides a strong upward push, so even organisms with weak muscles can still move around. The support provided by water is helpful in other ways, as well. Our heart muscle has to be very strong to pump blood upwards through our body against the force of gravity, something that ocean animals do not have to worry about as much since the surrounding water presses in on them and helps them fight gravity. Slide 4. Ocean life is in part classified, broken into different categories, due to the density of ocean water. Most ocean animals and algae are plankton, they try to float and are poor swimmers, or cannot swim, so they drift with the ocean currents. Animals which are stronger swimmers like dolphins, sharks, most fish, and so on can overcome waves and currents to go wherever they wish to and are called nekton. They rely on water's support much less than plankton. Animals and algae which live on the ocean bottom like anemones, clams, sponges, corals, and so on are called benthos, or benthic organisms. Most benthos do not have adaptations which lower their density, because they do not need to float. Slide 5. Organisms have a variety of adaptations which help them float, or at least sink slower. Recall that an object will float in the ocean if its density is lower than the density of ocean water, and sink if its density is higher than the density of ocean water. The bigger the difference in density between the object and the water, the faster the object will rise or sink. Thus, to float, an organism needs to have a body with a lower density than water. It will also float if its body has the same density as the water around it. If its density is just a little bit more than the density of water, it will sink, but very, very slowly. Many organisms have bodies filled with low-density substances like oils, fat, and gases. Marine mammals like whales have lots of blubber which not only helps them float, very important since they get their oxygen from air, not water, but also stores food and provides insulation, keeps them warm in cold ocean water. Some diatoms, a kind of phytoplankton, have a drop of oil in them. The oil is a way to store the energy captured via photosynthesis for later use and helps them float and get more sunlight. Kelp have bladders filled with carbon dioxide, helping them reach up towards the surface of the ocean to get sunlight. Some fish have special organs called swim bladders. The fish can pump gases into or out of their swim bladders to lower or raise the density of their bodies. Air adds more space than weight, so these fish inflate themselves like a child's water wings or a beach ball when they want to go upwards, and let out gases into the surrounding water when they want to sink. Many ocean animals have gelatinous bodies. Such animals are often called jellies, which are about 95% water, so they have nearly the same density as water. Slide 6. Most plankton have densities that are a little higher than the density of the ocean water where they live, at least some of the time. One common reason is that the plankton grow the thickest shell possible that still allows them to stay near the surface of the ocean. The heavier the shell, the stronger and more protective it is, but the weight of the shells increases density of the plankton as well. The density of ocean water changes over time, and this can cause a plankton to begin to sink. For example, ocean water warms up during the summer and cools down during the winter. It becomes fresher, less salty, when it rains, and becomes saltier when ocean water evaporates. If a plankton has a density which is close to the typical density of the ocean water where it lives, the plankton will begin to sink if ocean water becomes too warm or too fresh. In other words, the plankton sinks if the density of the ocean water decreases too much. Recall that warm water has a lower density than cold water, and fresh water has a lower density than salty water. It is especially bad for phytoplankton if they drift too deep, because they will die from a lack of sunlight for photosynthesis. This is why phytoplankton prefer higher density water. Cold and salty water. High density water helps them float, or, failing that, it pushes them upwards harder, so they sink very slowly. It should be noted their phytoplankton can benefit from sinking. For example, falling exposes phytoplankton to more water and thus increases their chances of encountering and absorbing nutrients. When the density of the ocean water gets too low for plankton to float, the plankton's strategy is to sink as slowly as possible, waiting for a passing wave to reach down and lift them up, or for the water to cool down or become saltier again and push them back up to the surface. Some organisms slow their fall with bulky, wide bodies that catch the water, like a parachute. Even small spikes and hair-like structures help. In some cases, animals spread out their bodies while they rest, and the pull in the structures to become more streamlined when they want to swim. In all of these cases, the key is that the organisms have more surface area, which produces more friction with the ocean water and slows their fall. Just being small helps too. Smaller organisms have more surface area relative to their weight, and thus generate more friction relative to their weight. For example, a cube with side length of L has a surface area of 6L squared and a volume of L cubed. So if a cube has sides that are 1 mm long, its ratio of surface area to volume is 6 per millimeter. If a cube has sides that are 2 mm long, its ratio is 3 per millimeter, so it generates half as much friction per unit weight as the smaller cube when it sinks. Thus, if two things have the same density, and are more dense than water, the larger one sinks faster. Slide 7. Most ocean animals eat plankton. Big fish and other large animals typically eat the small fish and other small animals. Small fish and other small animals eat zooplankton. The zooplankton eat the phytoplankton. Thus, only the big fish typically do not eat plankton. And some of the big fish and other large animals do eat plankton, animals like baleen whales and whale sharks. Slide 8. Just as water provides support for organisms, it also provides support for potential food. This means that animals do not have to go search for food, it can drift to them. This helps small, drifting larvae, baby animals, survive on their own in ocean water. However, it also works against them as well. Many larger animals have special adaptations for capturing tiny plankton drifting in the water. We call this filter feeding or suspension feeding. Slide 9. Some animals grab small plankton out of the water with arms, tentacles, legs, and so on as the plankton pass by. Examples include sea anemones, barnacles, and jellyfish. Other animals weave and cast sticky mucus nets to catch small plankton, and then pick them off the net or eat the entire net. Some mollusks and larvaceans do this. Some animals draw water into their bodies and put it through a strainer of some kind. The water goes through the strainer, but the plankton get trapped. Clams, sponges, some mollusks, and baleen whales use this strategy. Sessile animals take plankton eating to an extreme. They live most of their lives stuck in one spot and wait for the food to come to them. Many tide pool animals like sea anemones and barnacles are sessile, filter feeders. Here is the key point to take away from this section: oceanographers call plankton eaters filter feeders or suspension feeders. Slide 10. Water's density also affects organisms' reproductive strategy. On land, males and females must find one another and physically touch to mate. The males and females of most ocean organisms release their gametes, eggs and sperm, directly into the water where they meet and join at random and by chance. This method of reproduction is called spawning, specifically, broadcast spawning. The fertilized eggs develop into larvae, zooplankton, that drift in the water and feed on phytoplankton and smaller zooplankton. The parents do not care for the larvae, baby zooplankton, so the fertilized eggs and larvae, zooplankton, are very vulnerable to predators, filter feeders. Most get eaten, only a few lucky ones survive to adulthood. I will refer to this method of reproduction, of spawning, as the gametes meet randomly and become zooplankton method of reproduction, GMRBZ for short. For the gametes meet randomly and become zooplankton strategy to work well, the adults must be close to one another. The closer the gametes, eggs and sperm, are to one another, the more likely that they will meet. It can be dangerous to gather in large groups, because this attracts predators. Not only are many of the eggs eaten, but often many adults die. In some species, salmon and some squid, for example, this is part of their reproductive strategy. The adults spend all of their energy and resources, even their bodies, to ensure the survival of the next generation. In other words, their dead bodies help protect and provide resources for their children. Timing is also important for the gametes meet randomly and become zooplankton method of reproduction to be effective. All the organisms need to release their gametes at the same time. Everybody on a count of 3, 1, 2, 3 reproduce. If the gametes are released at different times, many of the first ones to be released will drift away before the next ones are released, so they will not meet. Often ocean organisms use natural cycles like the tides to determine when to gather and reproduce. There are other kinds of spawning. Some ocean organisms use a variation of gametes meet randomly and become zooplankton to reproduce. For example, a female animal might collect sperm from the water and use it to fertilize her eggs, releasing them later after the eggs have had time to develop and become a bit larger, and therefore less likely to get eaten. A benthic animal might release eggs and sperm into the water to meet, but then the fertilized eggs might drift for a while and settle on the ocean floor before developing into animals. In other words, they never become zooplankton. However, most ocean animals use the gametes meet randomly and become zooplankton reproductive strategy. Slide 11. Viscosity refers to how easily a fluid flows. A high viscosity fluid flows poorly, it oozes slowly, while a low viscosity fluid flows easily, it is runny. For example, toothpaste and honey have higher viscosities than water and oil. Viscosity is related to the amount of friction or drag in the fluid. The viscosity of the water makes it more difficult for organisms to move, particularly microscopic ones. In other words, high viscosity water is harder to swim through, it slows them down. However, high viscosity water also slows down sinking plankton. This keeps them near the surface longer. It can allow them stay close to the surface until conditions improve or something lifts them up, a wave, for example. Viscosity is affected by temperature. The higher the temperature, the lower the viscosity. Think of the syrup that you put on your pancakes. When you heat the syrup, it flows more easily, is runnier, than cold syrup. Viscosity is often related to density. A thick, dense fluid is often more viscous, that is, has a high viscosity, but they are not the same thing, so you must be careful not to confuse one with the other. However, note that temperature affects density and viscosity in the same way. A higher temperature lowers the density and lowers the viscosity. This means that warm water makes it harder for plankton to stay near the surface for two reasons: the water does not push up as hard, and they sink faster. In other words, cold water, low temperature water, has a high density, so it pushes upwards harder on plankton, and cold water has a high viscosity, so the plankton experience more drag, more friction, and thus sink slower in cold water. Slide 12. Open ocean temperatures range from about 30 degrees Fahrenheit to 90 degrees Fahrenheit, while temperatures on land range from about -125 degrees Fahrenheit to 136 degrees Fahrenheit. Thus, temperatures on land are much more extreme than those in the ocean. The temperature of the land gets much higher than the temperature of the ocean. But the temperature of the land also gets much lower than the temperature of the ocean. For example, the land gets hotter than the ocean during the summer, and colder than the ocean during the winter. This means that the ocean has a more stable environment than the land. As you might imagine, this makes it easier for animals and algae to live in the ocean. They do not need adaptations that help them survive in the very hot or cold conditions that land animals and plants experience. However, it also means that what seem like small changes to us, say the almost 2 degrees Fahrenheit change in the ocean due to global warming, is a much bigger deal to ocean life. There are several reasons for the more stable temperature of the ocean. When heated or cooled, water's temperature changes very little compared to other substances. Think about a hot afternoon at the beach, which is warmer, the sand or the water. In addition, when water molecules become too hot, they evaporate, leaving the cooler molecules behind in the ocean. Also, energy from the sun is distributed over a lot of water, not just the first inch of soil at the top, and waves and other phenomena mix cold water from below with warm water at the top. Slide 13. Many different substances are dissolved in seawater, not just salt. Salinity includes nutrients, needed by phytoplankton to perform photosynthesis, and gases like oxygen and carbon dioxide. Many ocean organisms' bodies are quite exposed to their environment. Substances in the water can easily drift in and out. Often this is a good thing for them. For example, phytoplankton shells are quite holy, allowing carbon dioxide and nutrients to drift in and wastes like oxygen to drift out. In general, randomly moving water molecules tend to move from the place where they are most concentrated to where they are less concentrated. In other words, their movement evens out differences so that the organism's internal saltiness gets closer to the ocean water's salinity. If ocean water is saltier than an organism, the organism is fresher or less salty than the ocean water. Water molecules will leave its body, moving outside to where there is relatively more salt and less water. The organism then suffers from dehydration, a lack of water. If you drink too much seawater, water from your body's tissues will move into your stomach, where the salt is, and then be lost from your body when you urinate. As a result, you become dehydrated. If ocean water is much less salty than an organism, the organism is saltier than the ocean water, extra water will enter its body, causing its cells, and the organism, to bloat. If the cells bloat too much, they burst. Like temperature, salinity also affects the density of seawater, making it easier or harder to float. The higher the salinity, the higher the density of the water and thus the stronger the upward push of the water, making it easier for organisms to float. Salt atoms are heavier than water molecules, so adding salt to water adds more weight than space, increasing the density of the water. Thus, changes in salinity do not just cause organisms' bodies to bloat or dehydrate, they also make it easier or harder for the organisms to float, or cause them to sink slower or more rapidly. Slide 14. Nutrients are atoms and molecules that are needed to get the food chain started. Plants and ocean algae need nutrients to carry out the process of photosynthesis, the process by which they make their own food using the energy in sunlight, and build some body parts, like their shells. The nutrients are not used up during photosynthesis, instead, they are used to build molecules needed to carry out photosynthesis. In other words, nutrients are needed to make molecular tools, like a hammer is needed to build a house or spatula is used to make a hamburger. The tools but are not actually used up in the building process, but can be used to make more and more houses and more hamburgers. Examples of nutrients include nitrogen and phosphorus compounds, and silica. On land, plants extract nutrients from the soil via their roots. When the plants die, their bodies are broken down by decomposers like bacteria and fungi, and the nutrients are returned to the soil for the next generation of plants to use. When we harvest plants on farms, we prevent this from happening, and this is why we need to use a lot of fertilizers when we farm. Fertilizers are substances that contain a lot of nutrients. Since we remove the plants and take them away, we are preventing the nutrients in the bodies of the plants from going back into the soil. We need to add nutrients to the soil by adding fertilizers so that lots more plants can grow in fields. Most new nutrients enter the ocean when rainwater runoff washes nutrients from the soil on land into the ocean. Slide 15. In the ocean, nutrients are not recycled as efficiently as on land. Over time, nutrients at the surface of the ocean end up moving deeper into the ocean. When ocean animals and algae die, their decaying remains sink downwards, leaving the sunlit waters at the surface where photosynthesis is possible. The animals also excrete wastes like fecal matter, poop, and this typically sinks as well. The dead bodies and wastes contain nutrients, and when they sink, they take the nutrients with them. The nutrients in the dead bodies and wastes are released into ocean water. As the dead bodies of ocean animals and algae and their wastes slowly sink, the dead bodies and wastes are decomposed, broken down, by bacteria. Decomposition releases nutrients in the dead bodies and wastes into the water. However, decomposition is a slow process, so dead bodies and wastes can sink down pretty deep before they are completely broken down. Thus, a lot of nutrients end up deep in the ocean, where algae cannot live due to the lack of sunlight. Here is the key point: over time, there are fewer and fewer nutrients at the surface of the ocean. The nutrients end up deeper in the ocean. This is bad for ocean algae, the phytoplankton, who need the nutrients so that they can carry out photosynthesis, so that they can make food for themselves using the energy in sunlight. And it is bad for the animals in the ocean, since almost all of them eat phytoplankton or the zooplankton who eat phytoplankton. If there are few phytoplankton in the ocean, there will be less food for ocean animals. Thus, most life in the ocean will be in places where nutrients are being added to the surface of the ocean. Near the coasts, nutrients are washed off the land by rainwater runoff, so many phytoplankton live near the coasts. The second major source of nutrients at the surface of the ocean is nutrients that are brought up from below, typically by waves or currents. In places where surface water is cold, waves have an easier time stirring up nutrients from below. In special places where winds and currents are going in the right directions, deep, nutrient-rich water is drawn upwards towards the surface. We call these places upwelling zones. Slide 16. Phytoplankton, tiny single-celled ocean algae, make most of the world's oxygen, and the ocean provides us with over half the oxygen that we breathe. Phytoplankton live at the surface of the ocean so that they can get sunlight for photosynthesis, the process by which they make food for themselves, just like plants on land. Oxygen is a byproduct, a waste gas, of photosynthesis and released into ocean water. Thus, most of the oxygen in the ocean is near the top where the phytoplankton live. Oxygen then leaks into the atmosphere from the surface of the ocean. Oxygen levels are highest at the surface of the ocean. Unlike the atmosphere where oxygen molecules move around freely, oxygen moves slowly through ocean water. Liquids are thicker than gases, the water molecules get in the way of the oxygen molecules. Thus, oxygen does not quickly or easily move downward through ocean water. However, oxygen levels are fairly high near the bottom of the ocean, because when oxygen-rich surface water becomes very cold and salty, it sinks to the bottom, carrying its oxygen with it. Thus, the part of the ocean with the least amount of oxygen is typically the thermocline, the middle layer of the ocean between the top and bottom layer. There are places in the ocean with very little oxygen. We say that the water in these places is anoxic. In some cases, oxygen levels can become so low that animals suffocate, they cannot breathe. We refer to these regions as dead zones. Oddly, the lack of oxygen is usually caused by an overabundance of phytoplankton. If zooplankton cannot eat all of the phytoplankton, there are too many, bacteria will grow abundant and decompose the phytoplankton bodies. The bacteria need oxygen to break down the phytoplankton bodies. Our bodies need oxygen to break down food molecules too. This is why we breathe. Thus, bacteria remove lots of oxygen from the water when they decompose a huge number phytoplankton bodies, resulting in a dead zone.